Hello, Algebra 1. This is 8.10, inverse variation. Earlier this week, we looked at direct variation. So remember, direct variation always had the form y equals k times x. And the ratio, if we solve for k, we get k equals y over x. And that's always constant. This is what direct variation looks like. With direct variation, both things are changing in the same way. So if y increases, x increases. For example, the distance that you travel will increase as the time that you travel increases. But there are some relationships that work in the opposite direction. Some relationships, when one value increases, the other value decreases. This is called inverse variation. Inverse variation. Some examples might be, as you increase your speed, the amount of time it takes you to get somewhere decreases. That's an inverse relationship. An inverse variation is a function. So this is our formal definition. An inverse variation is a function defined by an equation of the form x times y equals k, where k is a non-zero constant. Or you could write it y equals k over x, where x does not equal 0. All right, so I want to look at these carefully because these at first glance look very similar, but they have some key differences. Up here, we have a y equals equation with k and x together on the other side. That's direct. For inverse, we have x and y together and k by itself. So that's how you can identify the difference between direct and inverse. Who's being multiplied? Are k and x being multiplied for direct, or are x and y being multiplied for inverse? The other one we need to look at is the fraction. Are we giving the value of k as y over x? That would be direct variation. Or are we giving the value of y as k over x? That would be inverse variation. So you need to look carefully at the values, what's being multiplied together or what's being divided, so you can decide which one is direct and which one is inverse. When we read these, we would say that y varies inversely as x. Y varies inversely as x. Or you could say y is inversely proportional to x. I forgot some letters there. Inversely. You could say that y is inversely proportional to x. The constant k is still called the constant of variation. That's not changed. The constant stayed constant. Haha. So k is the constant of variation. Just like in direct. Same thing in inverse. All right, so if you look on page 398, there's a gray box in the middle of the page that compares these again, so it's worth repeating, so I'm going to put this here. I'd like you to copy this into your notes just so you can get this straight. So we've got direct variation and we've got inverse variation. Direct variation, y equals k times x. Inverse variation, x times y equals k. Or more commonly for inverse variation, you might see it as y equals k over x. As a matter of fact, I just finished teaching this unit in our Algebra 2 book. They present it more in this format, y equals k over x. So y varies indirectly as x. When you're comparing 2 points, 2 different values in the same relationship, when we did direct variation, we did some proportions where we had y1 over x1 equals y2 over x2. When we're doing inverse variation, we can compare 2 points using multiplication. So x1, y1 is going to equal x2, y2. So 1 point together, 1 point together, equal to the other point, equal to the other point. So for direct variation, we can set up a proportion. For inverse variation, we've got these 2 multiplications being compared to each other. So the equations show that for direct variation, the quotients of the coordinates are constant. And for inverse variation, the products of the coordinates are constant. So direct variation, constant quotient. Inverse variation, constant product. Okay, so an example that we can do with this, let's see. If we have x1, y1, and x2, y2 are ordered pairs of the same inverse variation. So our ordered pairs of the same inverse variation. So we're talking about this, inverse. Find the missing values. All right, so for the first one, if x1 equals 20 and y1 equals 7 and x2 equals 4, we want to find y2. So using this formula, x1, y1 equals x2, y2, we're going to plug in what we know. We know x1, y1. So we know 20 times 7, and we know x2 is 4 times y2. So 20 times 7 gives us 140 equals 4 times y2. Divide by 4. Remember, that's a notation. It's not actually any math happening right there. That's just a subscript. 140 divided by 4 gives us 35. So 35 equals y2. All right, let's try another one like that. If we have x1 equals 64 and y1 equals 3/8, we don't know x2, but y2 equals 6. And they've told us in the problem that this is an inverse relationship. So we have x1, y1 equals x2, y2. Plug in what we know. We know x1, y1, so 64 times 3/8. We don't know x2, but we do know that y2 is 6. All right, so we have to do some math with fractions. We can do this. 64 is understood to be over 1. When we multiply fractions, we will multiply across the numerators and across the denominators, or we can cross cancel. So 64 and 8 reduce each other by a factor of 8. So across the numerator, we have 8 times 3, which is 24. Across the denominator, 1 times 1, which is just 1. And then over here, we have 6 times x2. Then we're going to divide both sides by 6. 24 divided by 6 is 4. So x2 equals 4. All right, one common thing that we do with inverse variation is this idea of the law of the lever. A lever is a bar pivoted at a point called the fulcrum. If masses m1 and m2 are placed at distances d1 and d2 from the fulcrum and the bar is balanced, then m1 times d1 equals m2 times d2. This is the idea of like a seesaw at the playground. All right, so you've got this lever or lever, you've got the fulcrum in the middle, You've got some weight hanging off of this end and some weight hanging off of this end. This one is so far away from the fulcrum and this one is so far away. So this is our first mass. This is our second mass or weight. This is our first distance. This is our second distance. The relationship here, mass 1, distance 1 equals mass 2, distance 2. So anytime you've got this seesaw or lever type situation, this is how you would set it up. All right, so an example for that. Sorry, shifting through my notes here. A child with a mass of 25 kilograms is sitting 2 meters from the fulcrum of a seesaw. So the child has a mass of 25 kilograms sitting 2 meters from the fulcrum. So here's our child. Here's 2 meters, and this kid weighs 25 kilograms. How far from the fulcrum should a 100 kilogram adult, so we've got an adult, they're going to play on the seesaw with their kid, they're weighing 100 kilograms, and we want to know how far away should they sit to balance the seesaw. So we've got an adult over here on this end. They weigh 100 kilograms. We want to know how far away should they sit. Please don't stand on seesaws, you guys. But, you know, this is how I draw. So we need to figure this out. According to this law of the lever, we've got mass 1 times distance 1 equals mass 2 times distance 2. So we're going to use our child for our first numbers. So we've got 25 times 2. And then for our adult, we've got 100 for the mass, but we don't know the distance that we want to use for that one. So 25 times 2 gives us 50. 50 equals 100 times D2. We're solving for D2, so we're going to divide by 100. So 50 over 100 is 1/2. So he needs to be half a meter away. So check that out. This is the inverse relationship that I was telling you about. The child weighs less and is 2 meters away. The adult weighs more, so his distance gets smaller. His distance is only going to be half a meter. He's going to sit really close to the fulcrum to balance out the child sitting on the other end. That's an inverse relationship. As his mass went up, the distance from the fulcrum went down. Okay. I think that pretty much covers everything that's going to be in your assignment for this one. Going back to the beginning, there's going to be a section where you're just looking at equations and identifying whether they follow direct variation or inverse variation. So you may want to rearrange the equation they gave you to make it look more like one of these so you can decide if it's direct or indirect. Then you're going to have a set of exercises basically like this, where you're just plugging in the numbers that they gave you into the equation and solving for the missing value. And they may give you a few with the mass and distance where same thing, you're just plugging in the numbers that you know into the equation and solving for the unknown. You guys have a take-home test coming home in your next packet. So this is the last set of notes for the section on chapter 8. I want you to be making sure that you're doing these assignments diligently. Do the chapter review assignment that I gave you in this week's packet. The test will not be open note or open book. So you need to study for that test before you turn in your packet on Wednesday, because you're turning in all these assignments and you're not going to get them back till after you've taken the take-home test. So keep some notes for yourself at home. I do not need you to turn in your notes. I just need you to turn in your assignments. So turn in the assignments, keep the notes, study the book. Remember, you've got that set of pages in the back of the book around page 655 or so. There's a bunch of extra questions back there. If there's anything from chapter 8 that you're still having a hard time with, go back there. We're going to be testing over 8.6 through 8.10. So focus on those sections, 8.6 through 8.10. Find some odd numbered problems. Pick a few out to solve. Check your answers in the book. You guys know how to study. So this is coming home in your next packet, and then we're also going to be moving on to the next chapter in the next packet. So there will be videos releasing next week when you get to the new material. If you have questions, the official way to contact me is through my school email. So comments on the YouTube videos are not counting as contact. You have to email me to my school email address. My office hours are Mondays and Wednesdays from 10 to 12. So make sure you get all your questions in there by Mondays at 10 or by Wednesdays at 10. You can email whenever you want, and it'll be waiting for me when I log in during my office hours, and that's when I'll answer questions. You guys can also reach out to each other. Feel free to contact each other. And remember, there's tons of resources online. If you're not sure about how to do something and my video wasn't helpful, look up another video. There's Khan Academy videos. There's all kinds of YouTube videos that you can probably search by topic, like direct variation or inverse variation, and get another explanation if you want to hear it from someone else's point of view. I hope you guys are doing well, and stay healthy.